Question 9. Write the equation of the planes in the following cases. First one, parallel to xy plane and 5 units below it. So we'll take one by one. So first one is parallel to xy plane and 5 units below it. So if you have gone through the concepts of the plane I have discussed in the earlier video, this is quite simple and straightforward. So I will explain anyway. If you haven't referred that video, please refer that old video where I discuss these concepts. Okay, anyway, parallel to the xy plane and 5 units below it. So equation of any plane parallel to xy plane will be of the form z is equal to a. Let's show you why. So let x, y, z coordinate will be this x, y, z, and xy plane is of the form. So this is our xy plane. So this is z in the direction. So a plane parallel to xy plane and with z is equal to and 5 units below it. 5 units below it means, let's say here we have another plane like this, where any point on this plane is z is equal to -5. So since this is 5 units, so since this distance is 5 units, this plane will have will be defined by the equation z is equal to -5. Any point on this plane will have z coordinate as -5. So our required equation is z is equal to -5. So this is the solution to question 1. So let's take up the next question, question 2. So in question 2, we are asked to find the equation of the plane parallel to yz plane and having x-intercept 3. So any plane parallel to yz plane will be of the form x is equal to a. So it is directly given x-intercept is 3. So we can directly write our equation as x is equal to 3. So how will it look? Let's say our x that now plane parallel to yz plane. So yz plane will be like this, and any plane parallel to yz plane will something like this, and any point on this plane will have x equal to 3. The equation of this plane where any point on this plane is having x coordinate as 3 will be represented by the equation x is equal to 3. So this is our required equation. Now next question is plane perpendicular to the z axis at the point 0, 0, 4. So we'll just write down. We are asked to find equation of plane perpendicular to the z axis at the point 0, 0, 4. So if you see, these are our x, y, z coordinate, x, y, z. Any plane perpendicular to the z axis will be parallel to xy plane. That is the concept here. So if you take xy plane, it is perpendicular to the z axis. So any plane perpendicular to z axis will be parallel to this plane. So as we just discussed, a equation of a plane parallel to xy plane will be of the form z is equal to a. Now it is given perpendicular to the z axis at the point 0, 0, 4. So it will be somewhere here. So sorry, our equation, so our plane will be of this form. So where every point in this plane will be z is equal to 4. So here it is 0, 0, 4. So a plane perpendicular to the z axis at the point 0, 0, 4 will be z is equal to 4. This is our required third equation. Now our fourth equation, a plane parallel to zx plane and 6 units behind it. So we just discussed any plane parallel to the zx plane will be of the form y equal to a. Here I have and plane parallel to zx plane. Plane parallel to zx plane, and it is said in a plane that is behind it, where any point on this plane will be. So here, since it's behind this plane, it will be a form y equal to -6. Y equal to -6 or +6. This is our required equation. So here it could be written as z plus phi equal to 0 also. So these are the solution to the fourth question. As I said earlier, if you have gone through the concepts, the basic concepts, this will be very simple and straightforward question. This is question 9.